Hello viewers and welcome to a new STM32 World video. I don't think this will be a tutorial video as such, but a follow-up, so probably a short video just following up on some topics that I have covered lately. Now, by the time this is recorded, I just published, as you can see on the screen, the tutorial video number 62, where I cover actually testing the mysterious STM32F402 board. In that video, it is mentioned that the JLCPCB kindly sponsored an order of some boards, and the STM32F402 was, I think, perhaps the most important one in that order, but I had other boards made in as part of that order, and by the time this video will be published, the last one that will have been mentioned is this video, which is number 64, where I do a proper SD card breakout. Now, this SD card breakout is covered in that video, how I designed it, how I ordered it, how it is designed. It's essentially just an SD card holder with some pull-up resistors and decoupling capacitors. Very simple, very small, and it worked flawlessly. Now, I feel like actually doing a little follow-up on that video, the SD breakout board, because as part of that video I ordered, I went through the ordering process at JLCPCB, and I created in that order, I just ordered 10 of them, so 10 PCBs fully assembled except the header, which you see there, but everything else, is there a photo? Well, it was essentially without the header, but everything else was there. And I think that order, if I'm not mistaken, came up, I didn't order it, I just went through the ordering process, but it came up to $27 for 10. That is $2.70 a piece, which is quite a lot actually, but I mean, for a prototype it's extremely cheap, and I am always blown away that it's possible to make prototypes at this cost. But if you imagine actually selling these breakout boards, of course $2.70 would probably kill that project straight away. But I just want to show you the power, if you want, of mass producing PCBs. So if we go to PCB and put in the same order, but tweak that order a little bit. So let's go to the order now, and we add the Gerber file. It was, okay, I need glasses for this stuff. It was this one, revision B, that I used. So by default, when you upload these Gerber files, you will have a PCB quantity of 5. 5 is kind of the cheapest one because they give you a special offer. So 5, as long as they are less than 10 times 10 centimeters, you'll get them for $2 for 5. That's it. But imagine we wanted to make more than 1,000 of these. Let's see how that goes. Now, the easiest way to do that is actually to put them on a panel. So it is possible just to ask JLCPCB to panelize it for you. So what you do is you go in here and you say, well, okay, let's get 10 times 8. So that means each PCB will have 80 of these devices on, and we add a rail. They need the rail to be able to process that to assembly. So we add 2 5mm rails, so there will be a rail on top and a rail on the bottom, and then it can go through. So there will be, if we submit this and say we want them to panelize that, you can see now 5 panels will actually have 400 of these devices, and the price is $27. Now let's up this to, let's say we want to make 15. What is that? That's 1,200. So if you want to produce 1,200 of these boards, then it is 15 panels with 80 devices on each panel, and it will be 70. So we are talking about 70 cents or something like that per board. If you divide that, it's less than 70 cents actually. Let's do this and let's for fun make them black. Of course, when you order 1200 of something, you've got to be damn sure that you know what you're doing. But it's okay. I'm not going to actually order this. So 10 columns, A row, edge on top, 5mm panel size will be 330 centimeters times 20 centimeters. That sounds reasonable. And we do the usual. I actually don't think the order number is necessary in this case because I think they'll put them on the rail. I don't think they'll put them on the individual boards. So that's probably not necessary. Let's try to throw some components on this because this is where it becomes really interesting because they become quite a lot cheaper. So 15 PCBs with 80 of these on each PCB. Let's go next. Let's add the, well, file provided. I'm still giving them only one single piece and they need to repeat the data. So JLCPCB will handle that in the background. So let's give them a bill of material and let's give them a position file and let's proceed with that. Here we go. Unmatched component again. We are not putting the connector in, but this is where it gets fun. 7,200 resistors, and they cost $4 for 7,000. So it becomes this more than 10,000 components here that we are going through. And let's go next. And it will still complain about that header, but we don't want that header, so let's move on. Here we go, and they will show you should also always verify that the components look like they're placed correctly. And we have the capacitors, we have the resistors, we have the SD card holder, and that is all there is to it. Let's see what that cost. Okay. So roughly $1,000, probably shipping. No. It will not even be $900. So $900 for 1,200 of these. So if we, where do we have? So 898 divided by 1,200. I can't do that. 70. Okay, let's say 75 cents if we include the header in the back when reserved. So the cost of these will be 75 cents a piece if we order 1,200 of them in one go. So all of a sudden, if we sold this for like $2, $3, $4, there would actually be quite a decent profit, but it needs to be made in volume and you need to find $1,000 to actually play with this, but it is possible. Anyway, that was a bit of a side note. What I want to talk about today is that as part of this breakout board, which we can talk about in detail, I also made a board for my STM32World series because that is easier for me to deal with. So if we look at the schematics of this, it is a little bit more complicated than the previous schematics. A small disclaimer, my apologies for the PCB. It's a rather messy layout, but that was messy because this was a last minute thing. I had actually prepared that order for JLCPCB and I just decided, well, why not throw this on as well because it doesn't cost very much to add this. So basically, to talk about this, so first of all, it will have those stackable pin headers in the side, but the actual schematic is the same. We have the SD card, we have the pull-up resistors. The difference is that I have some solder jumpers on this board, and the solder jumpers are meant to make this board configurable because you stack it up with some other boards, and well, SDIO might not be available, so this one can be swapped to SPI. SPI. So up here you will see a bunch of double solder jumpers here. So if they are jumpered up, it will be SDIO. If they are down, it will be SPI. So depending on where you put these 6, 1, 2, 3, 4, 5, 6, it will be either SDIO or SPI. And down here, if you select SPI, you can see we have it is either SPI1, SPI1 alternatively, all right, SPI2. I actually think there might be a problem here. Anyway, let's not bother with this right now. And if we look at the board view in 3D, you'll see you have the SD card holder over here, and you have the pull-up resistors, and then you have all these solder jumpers. So you solder jumper this way, it will run SDIO. If you solder jumper the other way, it will run SPI, and then you have to select over here which SPI you are actually using. So let me, I think it's here. Let me show you how this actually looks. Let me get a bit more light. Can I show you this? Yeah, I can. So here we have the board, we have the SD card holder, we have these solder jumpers, and as you can see, I don't know if you can see that, over here you have the SDIO or SPI selection, and over here on the cheap side you have which SPI we are using. I have actually only tested it on SPI1, so I better check it if it actually works on the other ones. But that is the board as it came out. And if we look at my desktop right now, I have, where are we? There. I have this board stacked on top with an SD card in it, and it is stacked on top of a MCU board. It's probably the F405, or it is the F405, and below that we have an SD link which is hooked up to my USB. Well, needless to say, because I mean I recorded the SD card breakout video. I recorded that yesterday, and it ended up with me actually testing the firmware, loading the firmware onto this board. Now it's exactly the same board, so I can't even be bothered to going through the process. All I will do is I will show you the output of this. Hang on, wait. I just disconnected the USB because I think I got a terminal running somewhere else, but I reconnected the board there. And let's fire up this one again, and let's reset. And as you can see, remember this one was strapped to SDIO. And yesterday I tested the breakout board with SDIO, and it works exactly the same and exactly the same speed, 290 milliseconds to read 1 megabyte, so read roughly 3 megabytes per second. It can read from this through FATFS on top of the SDIO using the SD card using SDIO. So again, I am grateful for the support that JLCPCB has given me. It's giving me a lot of tools to make more videos and make some indeed very interesting videos. So that is pretty much all I want to say in this video. This is not, as I said, not going to be a tutorial video. There will be more of those coming with boards that I actually made as part of the same order. But that's about it. 2 SDIO breakout boards that work flawlessly. And I need to point out that even with my old system where I just soldered some wires, long jumper leads on it, the fact that these boards have strong pull-up resistors make all the difference. That is what makes it reliable. You can run longer wires, and you will have less problems. So a relatively strong pull-up. I use 4K7 resistors, which is considered a medium strong, I would say. It's not a strong pull-up, but it's definitely also not a weak pull-up. So that's about it. There is a link down in there will be a link down in the description for both the SD Breakout Board article on the STM32World Wiki, and there will be a link to JLCPCB where they will give you a coupon or 3. I think they promised 3 coupons, and if you're signing up as a result of that, I think you get a $70 coupon as well for your first orders. It is quite good. It is unbeatable when it comes to prototypes, so give them a check. As usual, have a wonderful rest of the day.